Welcome, my dear students in Prep 2. Let's continue our geometry lessons. Our lesson today is about similarity. We studied before in Prep 1 congruency. Do you remember congruency? We said that two polygons are congruent if the corresponding angles are equal in measure and their corresponding sides are equal in length. Today, we want to study similarity, and we say that two polygons are similar, not congruent. Two polygons are similar if their corresponding angles are equal in measure and at the same time their corresponding side length are proportional. What does it mean? It means, for example, here if we have two polygons A, B, C, D, and this polygon is similar, this symbol means similar to the polygon XYZ. The first condition to be similar, their corresponding angles are equal in measure. Look at here, we have corresponding angles. Here, angle A and angle X. So measure of angle A equals measure of angle X. And by the same way, measure of angle B equals measure of angle Y, and measure of angle C equals measure of angle Z. And finally, measure of angle D equals measure of angle L. Okay, this is the first condition. The second condition, that the corresponding sides are proportional. It means the length of side AB over the length of side XY equals the length of BC over YZ equals the length of CD over the length of ZL and equals the length of AD over the length of XL, and all is constant. Okay, so that's what we mean by proportion, and this is equals to a constant. This constant is called the ratio of enlargement. This constant is called the ratio of enlargement or the drawing scale. Okay, this ratio or this drawing scale can be greater than 1. If this drawing scale or the ratio between sides is greater than 1, it means that polygon 1 is enlargement to polygon 2. If it's less than 1, it means that the polygon P1 is minimizing of polygon P2. And if it's equal to 1, it means that the side length also, the corresponding side length are equal. So the two polygons are congruent. Okay, so if it's greater than 1, enlargement, less than 1, minimizing, and equal to 1, it means they are congruent. We can note that the congruent polygons are similar. The congruent polygons, it means they have the corresponding angles are equal in measure and the corresponding sides are equal in length. So the ratio will be 1 to 1. So they are similar with the ratio 1 to 1. But it's not necessary that the similar polygons are congruent. Yes, because we have some similar polygons with a ratio of enlargement or minimizing doesn't equal 1. So the congruent polygons are similar, but it's not necessary that the similar polygons are congruent. All regular polygons are of the same number of sides are similar. Why? Regular polygons, it means all sides are equal. All sides are equal. And at the same time, the angles, the interior angles are equal in measure. We can calculate the measure of one interior angle in any polygons if we have the number of sides equals n minus 2 multiply 180 over n. This is the measure of one interior angle in a polygon. If this polygon, for example, is hexagon, then n equals 6. Heptagon, n equals 7. Quadrilateral, n equals 4, and so on. So all the regular hexagon have the same measure of the interior angle. All the regular quadrilateral have the same measure of the interior angles, and so on. So they have the corresponding angles have the same measure, and the corresponding sides or proportional. If each of the two polygons are similar to a third polygon, it means that the two polygons are similar. In the opposite figure, we have two parallelograms. Parallelogram ABCD similar to parallelogram XYZ. I want measure of angle Y, and I want the length of XY. Okay, let's see. Measure of angle Y, because the two polygons are similar, so measure of angle Y will be the same as measure of angle B. I want to calculate measure of angle B. This is a parallelogram. So each two consecutive angles are supplement. If this angle is 60, so this angle is 120. 180 minus 60. What about the length of XY? I write the proportional side to get the length of XY. So here the measure of angle B will be the same as the measure of angle Y equals 120. Okay, now I want to write the proportional sides. Here, for example, we have the length of ZY, so CD, I write the proportional again from the beginning. We have AB over XY. So this is the first ratio, AB over XY. What do we have? We have AB3. We don't have XY. We don't have XY. We want the XY. Okay. Also, we have BC over YZ. Here we have BC and we have YZ. Okay, so let's substitute. AB equals 3, so 3 over XY equals BC equals 4 over YZ is 2. So 3 over XY equals 4 over 2. To get XY, I'll multiply 2 by 3, then I'll divide by 4. 2 multiply 3 over 4 equals 1.5. So this is the length of XY. What about triangles? If we have triangles, I'll study the similarity of two triangles. Two triangles are similar if only one of the two conditions satisfy. The first condition, the measure of their corresponding angles are equal, or the length of their corresponding sides are proportional. We need only one condition to be satisfied to say that the two triangles are congruent. Okay, the two right angle triangles are similar, sorry, not congruent, similar. The two triangles are similar if one of the two conditions is satisfied. The measure of their corresponding angles are equal, or the length of their corresponding sides are proportional. Okay. Also, the two right angle triangle are similar if the measure of an acute angle of one of them equal to the measure of an acute angle in the other. Because here we have, for example, a right angle triangle, so this angle is 90 degrees. We have one of the angles is 90 degrees. If another angle, if a second angle, one of the two acute angles equal to the corresponding, then it means that the third angle will be equal, because the summation should be 180. Number two, the two equilateral triangles are similar. All equilateral triangles are similar. Why? Because they have the same measure of angles, or the angles equal 60 degrees, or each interior angle in an equilateral triangle equals 60 degrees. The measure equals 60 degrees. So all equilateral triangles are similar, or equilateral triangles are similar. The two isosceles triangles are similar if the measure of an angle in one of them equal to the measure of the corresponding angle in the other. So one angle is enough. If you have isosceles triangles, this is an isosceles triangle and this is an isosceles triangle. If only one angle here equals the corresponding angle in the other, then the two other angles will be equal. It means that the two triangles are similar. Okay, that's all about our session today. I hope you have understand. Next session we will talk about converse of Pythagoras theorem. Thank you very much for watching. See you next session and goodbye.